request of one of my subscribers, my daughter Sabine Fatma has requested me. I'm not actually um, uh, giving the videos of AS level, so she requested me, sir, kindly also record the videos for AS level. So I have decided I will go for now AS level, so many videos continuously for AS level. So this is for Sabine, especially Sabine Fatma. I will start from the vectors. I actually left at the vectors. Today we will be doing the addition of vectors. Addition of vectors, and especially first I will discuss the addition of two vectors only. So the short rules for addition of two vectors. Let us see how we can add two vectors if they are given. For addition of two vectors, actually there are two methods. One is the parallelogram method. One is the parallelogram method, other is the trigonometric method. So let us see how we can use the parallelogram method. Actually in parallelogram method we sketch the things, we draw the parallelogram and then on the scale, and then we do. For example, suppose if there is one question, it says I will do this question both by trigonometric method and both by parallelogram. Now suppose he says two forces of magnitude 60 Newton and 70 Newton. Two forces of magnitude 60 Newton and 70 Newton at an angle of 30 degree. At an angle of 30 degree with each other. Find the resultant. Now first I will solve this part by using the parallelogram method, then I will be using the trigonometry method. First, because I have to set the scale first initially, I am doing first by the parallelogram method. Now here the geometry and other things are not possible for me. I have solved this question on the paper, and then I am just giving you what the measurements you will be you will obtain. So I'll set a scale. I'm setting a scale which divides both 60 Newton and 70 Newton. So I'm suppose setting 10 Newton is equal to 1 centimeter. So 60 Newton will be 6 centimeters and 70 Newton will be 7 centimeters. So now the case is, I will just draw, suppose this line is 7 centimeters up to here, and this line they make angle of how much? 30 degree with each other. I'll make a 30 degree angle, and this is the 30 degree angle. With the protractor I'll make 30 degree angle, and I'll take this as 6 centimeters. This is 6 centimeter. Now I'll find the by parallelogram method the addition, the resultant of these two vectors. Now you open the compass. Open the compass because I want to make a parallelogram. I'll open a compass equal to 7 centimeters. Suppose I'll open the compass like this one. I want to complete a parallelogram. This is 7 centimeter, so I have to bring it 7 centimeter here, and I'll place a compass like this one. It will cut like this one. I will give an arc of 7 centimeters. Because from this is at a radius of 7 centimeters, so all points are at a distance of 7 centimeter. Then this is 6 centimeter. I'll open the compass of 6 centimeter, place it here. Of the 6 centimeter, this will be the 6 centimeter, and suppose this is for 6 centimeters. I'm sorry, I can make this way. This will be the parallelogram like this one. You may have one arc here and one arc here from this one. this arc of 6 centimeters, this arc 6 centimeter, this arc will be 7 centimeter. So this is the resultant. I'm sorry, I'm just showing it a method because actually you can draw it on the by using the exact trigonometry instruments. You can draw first this line 7 centimeter, draw this line 6 centimeter, open the compass equal to 7 centimeter, place it here. Now draw this arc. Then again open this 6 centimeter, open the compass 6 centimeter, draw this. Now this is the resultant, this are the resultant, and this is the angle which is made with the 7 centimeter line. So now you can, if you wish, you can draw 6 centimeter down and 7 centimeter up. So now let us see what these values are coming. If you measure with the this with the scale, this value of R coming out to be 12, it is coming 12.6 centimeters, 12.6 centimeter. And if you measure the angle, this is 14 degree. So this will be exactly, I have drawn it exactly on the paper. You can draw 7 centimeter, 6 centimeter, open a compass and do it. So this is 7, I will write the result. It's 12.6 centimeter is 12.6 multiplied by 10. So it is 126 Newton. 126 Newton. I will write resultant is 126 Newton at 14 degree with 70 Newton force. If this is 14 degree, this must be 16 degree. You can write this also. Resultant is 126 Newton at 16 degree with 60 centimeter force. 60 Newton force also you can write if you wish. So this is 14 degree with 70 Newton and 16 degree with this one. But the resultant is one. This is one question. Suppose always it means we have to make a parallelogram. Now if I want to solve this on a trigonometric method, I must know actually the law of sines and law of cosines. First I will discuss the law of sines and cosines for solving this by the method of the trigonometry. Now actually if this is the triangle, this is suppose A, this is suppose B, this is suppose C. The opposite side of this is denoted by small a, this by small b, this by small c. Now law of sines states, the law of sines, I can say, if I can take sine of this angle A, sine of A upon A must be equal to sine of B upon B, must be equal to sine of C upon C. This is the law of sines. And other one is the law of cosines. Law of cosines states that suppose if I want to find the value of A or A square, suppose I want to find the length A, I will write A square will be equal to, this is the A square will be equal to B square plus C square minus 2BC and cos of the opposite angle A. Suppose if I want to find B square, I will write B square, this one B square will be A square plus C square minus 2AC and cos of B. And similarly, if I want to find C square, it will be A square plus B square minus 2AB and cos of C. So this is very much clear. I think you know these by your O levels and mathematics. These are the rules. Now while using this rule and the very basic rule of the vector addition by the which we call head to tail rule, we can always have this notation. Now directly you can take 60 and 70 Newton directly if you wish. So what I will do, I can take suppose 70 Newton here, 70 Newton, and this is, I am taking this as 60 Newton and this angle is 30 degree. Now I have to use the head to tail rule method. I have just drawn this on a sketch, just put the values. Okay. Then I suppose again I will redraw this. Suppose this is 70 Newton. If I place this 30 degree over here, If I place this 30 degree over here, suppose 30 degree, I am placing it here 30 degree. If this is 30 degree and this is 60 Newton, if this is 30 degree, this must be 150 degree because this total is 180 degree. So this is 30 degree, this must be 150 degree. Now these two vectors are being added by head to tail rule. So this will be my resultant R. Now this is my resultant R. Now I can find by using the cosine rule, R square will be equal to what? You can have 70 square plus 60 square minus 2 into 70 into 60. Just I am deleting this figure now. 2 into 70 into 60 into cos of 150 degree. So this is R square, and if you are supposed to use all these values in your calculator, I tell you cos 150 will be minus an exact value you will be getting 125.6 Newton. Since I have already calculated this thing, so I am just writing the values 125.6 Newton. Although in drawing our value was 126 Newton, you can roughly say this is 126 Newton also. And now if you want to find this angle theta, you can use the law of sines. You can say sine theta upon 60 will be equal to, this is sine 150 upon the value of R is, you should use exactly 125.6 Newton, and when you calculate this, theta will be coming out to be, this is with the 70 Newton, theta will be coming out to be, you will see, I'm just calculating, I think that will be coming exactly at the 14 degree. So I can say the resultant is 126 Newton at an angle of 14 degree with the 70 Newton, or I can say the resultant 126 Newton at an angle of 30 degree, because now this is the resultant at an angle of 16 degree, sorry, with the 60 Newton force. So this is the method by with the trigonometric method. Let us go another example. For example, I'll be solving another example. Already I have solved here, so I will just writing it here and will be letting you know. I'm sorry I cannot produce here the, I tried my best to have the trigonometric instruments here, but I was unable. So suppose the question is, he says, suppose if two forces of 50 Newton and 70 Newton make an angle of 150 degree with each other, find their resultant. The resultant means we have to find the magnitude of the resultant and also the direction. Now I will select the scale. The scale I am selecting same. I am taking the scale, same scale I am taking 10 Newton is 1 centimeter. Always you should select a scale which divides both of these values, or you can take the HCF. So now my scale is 10 Newton is equal to 1 centimeter. I will draw roughly first. For example, the 70 Newton, it's usually a fact that we usually have the bigger value down. So suppose, or it's up to you. It doesn't matter whether you are drawing the bigger value or other value. It is the same thing actually. So suppose if you want to draw, now suppose I am drawing the 50 Newton downwards. It's up to you. 50 Newton here, and this is the 70 Newton here. 15 Newton means this is 5 centimeters. This is 7 centimeters at an angle of 150 degree. This one I am writing here. How will you draw it? 5 centimeter exactly, an angle of 150 degree, and this is the 7 centimeters. Now I will make a first a parallelogram. I will open 5 centimeters radius and I'll put it here. I'll open just like this one, so that a parallelogram is made like this one. The arc will cut it here. So if you see, this is the parallelogram made, this one. So this is the resultant. This is the resultant. You can see I will just open a compass of 5 centimeter, place it here and draw an arc this one. Then I'll open 7 centimeter and place it place it here and draw this arc. There will be this will be the arc here, you can see. If I draw 5 centimeter, it comes here in this way. If I draw 7 centimeter, it comes like here in this way. So now you can have this thing like this. I'm telling this is just a rough sketch. You can draw it exactly, this one and this one. So clearly this is 5 centimeter, this is 7 centimeter. But this is the resultant. We are least concerned about if you not even join dotted, this is up to you. So now this was 150 degree actually, this one. Now this is the resultant R. Now if you measure this resultant R, it is coming out to be almost 3.7 centimeter. When it is 3.7 centimeters coming, so I will say the resultant is 3.7 multiplied by 10, which is how much? 37 Newton. So I will say the resultant is 37 Newton at an angle of, I can have two angles measured here. If suppose if I am making this angle with this 50 Newton force, this is 50 Newton force, actually you will see this angle will be 71 degree. So I will say resultant is 37 Newton at an angle of 71 degree, 50 Newton force. Or I can say, in other words, resultant is 37 Newton at an angle of, this total is 150. So 150 minus 71, 79 degree with 70 Newton force. I can write in that way also. So this is the actually method for the parallelogram. Now if I want to solve this by the trigonometric method, how I can solve this by the trigonometric method? Let us see. Similarly, same, I will first, I'm not in trigonometric method, no need to take the scale, just use these 50 Newton, 70 Newton values. So this is 50 Newton, I'm making it down. Actually it is better to have the 70 Newton down, but doesn't make a difference. 50 Newton, and this is 70 Newton here at an angle of 150 degree. So just if I want to write here, this is 50 Newton. My head to tail rule method is 150 degree here. I'll place 150 degree here. This is 150 degree. So this must be 30 degree, this one. 30 degree, and this is 70 Newton. To go 70 Newton. And this is the resultant R. So I can calculate R by using the law of cosines first. Then I will find the resultant. So if I want to find the R square will be equal to 50 square plus 70 square minus 2 into 50 into 70 into cos 30. And when you calculate this is R square, and we will be calculating R, it is coming exactly 36.6 Newton. So trigonometric method is more accurate. In drawing we just calculated 37 Newton, but here it is coming exactly 36.6 Newton. And if this angle is theta, I can find this theta by sine theta upon 70 is equal to R is 36.6 upon sine 30. Sorry, it is sine 30 upon this is 36.6. So in that way, if you want to calculate this theta coming out to be 71 degree approximately. So I will say resultant is 36.6 Newton at an angle of 71 degree. This is the method how we add the two vectors. So we add usually two vectors either by the parallelogram law method, or parallelogram method. You can also call parallelogram law method. Or second one is trigonometric method. In parallelogram method, you make a parallelogram. Okay, and in trigonometric method, you first make use of the head to tail rule, and then use cosine rule for finding the magnitude, and then you use sine rule for finding the angle.